We are solving the modern physics problems of IIT-JAM 2021. This is 2-mark MCQ. This problem is related to nuclear physics, in which a particle, radioactive particle A, decays to B and B decays to C. The decay constant for A to B is lambda A and B to C is lambda B. The number of nuclei B is given by N naught lambda A lambda B minus lambda A into exponential e की power minus lambda A t minus e की power minus lambda B t. So for when t is small, we can exponentially expand the exponential term, that is NB can be written as N naught A, N naught lambda A divided by lambda B minus lambda A into 1 minus lambda A t minus of 1 minus lambda B t, which give us N naught lambda A divided by lambda B minus lambda A into lambda B minus lambda A t. So NB is equals to N naught lambda A t. That means our option A is correct. Here 4 statements regarding the nuclei are given. First one is uncertainty of momentum in nucleus is roughly 10 to the power 4 times the uncertainty of momentum of electron. Now for this statement we all know it. Regarding statement 1, delta R into delta P is of the order of h cross by 2. So delta R for E, delta P of E would be order of h cross by 2, and similarly delta R of P into delta P of P is also of the order of h cross by 2. That means delta P of P and delta R of P is equals to delta R of E into delta P of E. That means delta P of P, delta P of E is equal to delta R of E into delta R of P. We know is the radius of electron is 10 की power of the order 10 की power minus 10 meter, and for proton 10 की power minus 15 meter. So this momentum is of the order of 10 की power 5. So that means our first statement is correct. So statement 1. Now coming back to the next statement. Statement 2. We know it, volume of the nuclei is 4 by 3 pi r cube, which can be written as 4 by 3 pi r naught a की power 1 by 3, which can be written as 4 by 3 pi r naught cube a. So the volume of nucleus grows linearly with number of nucleons in it. Yes, V is linearly proportional to A. Statement 2 is also correct. Now coming back to statement 3. Statement 3 says energy of gamma rays due to de-excitation can be ordered. Yes, energy of gamma rays is always of the order of M maybe. And statement 4 is about Fe stability. Iron stability of the nucleus, and we all know it. Iron is the most stable element. So that means our all four statement A, B, C, D are correct. In this problem, we have been provided a wave function for the particle inside an infinite square well of length L. That psi of x is 1 by root 3 psi 1 x plus 2 by 3 psi 2 x. Or we can also write it in standard notation 1 by root 3 psi 1 x plus 2 by 3 psi 2 x. Now, the question is saying determine the correct statement. First, we all know it, average P is always 0, and for this state it is also 0. You can check it out. Average P is written like psi P psi, which can be represented as 1 by 3 of psi 1 P psi 1 plus 2 by 3 of psi 2 P psi 2. Now P psi 1 we can just do for one case. We would be having it 2 by a 0 to a sine pi x by a minus IH cross del by del x to sine pi x by a dx, which gives us minus 2 IH cross 2 by h cross by a pi a 0 to a sine pi x by a cos pi x by a dx, and this can be written as minus IH cross pi by a 0 to a sine 2 pi x by a to dx minus IH cross pi by a minus a by 2 pi cos 2 pi x by a 0 to a, which is equals to 0. Similarly, psi 2 p psi 2 is equals to 0. That means average p is equals to 0. Average p square is equals to probability pi into p square. Here, which probability for first term is 1 by 3 and momentum in this case is pi square h square by a square. Similarly, for second term is 2 by 3 into 2 square pi square h square by a square, which give us 3 pi square h square by a square. So delta p would be root over एवरेज पी स्क्वायर माइनस का एवरेज पी का स्क्वायर which give us root 3 pi h cross by a can be written as root 3 h by 2a or L. Energy for this question is average energy would be given by summation pi ei which is equals to 1 by 3 energy for first state pi square h square by twice ma square plus 2 by 3. Second is 2 square pi square h square by 2 ma square. So we would be having it 9 by 3 pi square h square by 2 ma square, that is 3. So here we would be having it 3 by 8 h square m a square. So our first three statements are correct, and average x question is saying delta x is 0, but for this system delta x is not equals to 0. One can calculate that like we did for momentum. So here our statement A, B and C are correct. That means A is correct, B is correct, C is correct and D is wrong. In the present problem, a particle is moving with a velocity of point AC in an inertial frame S1. So that this is S1. Now the particle is moving with velocity like this one, if it is X and if it is Y. Now there is another frame inertial S2 and it is moving with velocity 0.8 c. Now the question is asking it, let E1, EV2 are the relative velocity of the particle. That particle is having E1 velocity in frame S1 and E2 velocity in frame S2. Now we have to determine the ratio E2 by E1. So in frame S1, the energy of particle is given by E1 is equals to mc square is equals to m0 c square divided by 1 minus u s1 p by c का square, and we know it m0 c square. The velocity of the particle in frame 1 is nothing but 0.8 c, that can be written at 0.8. Now we would be having it here m0 c square divided by 0.6 10 by 6 m0 c square or equals to 1.67 m0 c square. In this frame, velocity of the particle will be as P1, S1P will always be 0.8 c. This is what the particle is having it. Now when we are talking about the observer or the energy of the particle in this frame. Now we have to use the relative velocity addition formulas. In frame S1, velocity of particle is particle R ux dash is equals to 0, uy dash is 0.8 c and v is 0.8 c. Here I am defining it ux dash, uy dash. The velocity of particle observed in frame X will be ux and uy. So velocity of particle in frame S2 is ux is equals to ux dash plus v divided by plus ux dash v by c square, which is equals to 0.8 c. Similarly, uy would be uy dash 1 minus v square by c square divided by 1 plus ux dash v by c square. So here uy is 0.8 c, 1 minus 0.8 square. So here uy is 0.48 c. Now, so resultant velocity of particle in frame S2 is u S2p will be ux square plus uy square, which is 0.8 c square plus 0.48 c square give us the value 0.93 c. So energy of the particle here would be m0 c square divided by 1 minus u S2p square by c square, which is equals to m0 c square 1 minus 0.93 square. And this E2, I would be writing it here, would coming out to be 2.78 m0 c square. Ratio E2 by E1 would be equals to 2.78 m0 c square divided by 1.67 m0 c square is equals to 1.66. In this problem, 20 spin half particle are distributed in different energy level. We know it. Degeneracy for 3D oscillator 3DHO is given by Gi is equals to 1 by 2 n plus 1 into n plus 2. So let us take in ground state G0 is having degeneracy 1 by 2, 1 into 2, that is 1. G1 is having degeneracy 1 by 2, 1 plus 1 into 1 plus 2, that is 3. G2 is having degeneracy 1 by 2, 2 plus 1 into 2 plus 2, that is 6. Now our work would be done. So distribution would be like this one. N is equals to 0, you would be having 1 energy level. For N is equals to 1, you would be having 3 degenerate state, and for N is equals to 2, you would be having 6. Now we have to distribute 20 particles in this energy table, 2 here, 2 here, 2 here, 2 here. Now 2 here, 2 here, 2 here, 2 in this state, 2 in this state, 2 in this. So that means 12 particles are in N is equals to 2 state. 6 particles are in N is equals to 1 state, and 2 particles are in N is equals to 0. For 3DHO, energy would be N plus 3 by 2 H cross omega. So that means for N is equals to 0, E0 would be 3 by 2 H cross omega. For N is equals to 1, we would be having it 5 by 2 H cross omega, and for N is equals to 2, we would be having it 7 by 2 H cross omega. Now distribution would be like this one. E0, EG would be 2 into 3 by 2 H cross omega plus 6 into 5 by 2 H cross omega plus 12 into 7 by 2 H cross omega. So we would be adding up this thing. 84 plus 30, 114 plus 6, 120 is equals to 60 H cross omega. So my answer here is 60. Characteristic wavelength K alpha for X-ray photon having molybdenum from molybdenum. Atomic number 42 is, in terms of angstrom, is. Now, characteristic wavelength is given by this relation, 1 by lambda K alpha is equals to 3 by 4 R infinity Z minus B square. So lambda K alpha is equals to 4 by 3 R infinity Z minus B square. Here P is equals to 1, Z is equals to 42, and R is equals to 1.0 10 की power minus 10 की power 7 per meter. Substituting this value, lambda K alpha is equals to 4 by 3, 1.09 10 की power 7 into 42 minus 1 whole square would give us 0.73 angstrom. 0.73 angstrom.